On episode 4 of the Agentic Advantage, Masaki and I are going to talk about an actual process and how companies of all shapes and sizes can leverage AI agents, traditional robots, and humans in the loop, all in an orchestrated process to drive efficiency.
That's right. And we're going to take the long origination use case as today's example.
Masaki, it's great to be back with you on episode 4 of the Agentic Advantage. And I'm excited today because we get to dive into an actual process and show our audience how you bring together AI agents, traditional robots, and humans all in one orchestrated process. And we're going to look specifically at an example in UiPath's latest white paper, which we'll bring up on screen, called The Definitive Guide to Agentic Automation. And this white paper has great topics like why agentic, the approach to agentic, the value to be gained from agentic, the backbone, what we call orchestration or agentic orchestration. And then we talk about things like security and governance. So we give examples, of course. We talk about and share customer feedback and testimonials. And then we give the audience in this white paper kind of what we refer to as the path forward. So I'm excited to dive into this white paper and show the audience this one example. And let's go to it now on page 10. So this is an example, Masaki, of a mortgage application process that leverages not only AI agents, but also traditional robots and, of course, humans in the loop. And this process is, like I've already said, is orchestrated in the UiPath platform. So this has six steps. I know we could probably add or subtract to this, but let's follow this process, Masaki, and talk about each of these steps and give the audience a view or a lens into each of them and maybe unpack them a little bit. Does that sound like a good use of time today?
Yeah, sounds good. I love the use case, by the way, because it's been a really great use case for UiPath, even without the agent context, as UiPath has been really good at document understanding, RPA portion, and we already have a lot of customers who does this process without agent. And now I'm very excited to include now agent portion on top of the existing automation. So yeah, I'm very excited to talk about this topic today.
Yeah, I'm glad you mentioned document understanding. And just so that our audience knows, if they're not familiar with what that is, it's really intelligent document processing, right? It's leveraging AI, it's leveraging machine learning, it's leveraging natural language processing in an OCR-like environment where we can read both structured, semi-structured, and unstructured documents. And that really does come into play here. I mean, you and I, Masaki, have worked with a specific customer I'm thinking about who does this loan origination process, but they implemented this years ago when agents weren't even on the scene yet. And so now I think what's exciting is to go back to that customer and customers like them and introduce agents into the process to add even more value in that continuum. But for now, let's talk about this process here on screen. The first step in this process that we're going to share today is really what we refer to as the trigger, or you might call it the initiation phase. And this is really where the journey begins as the customer submits, in this case, a mortgage application. This application is really the trigger that instigates the overarching agentic orchestration workflow. And then these workflows, of course, are made up of tasks for people, they're made up of robots, and of course, they're made up of AI agents. So Masaki, maybe for the audience, could you unpack this first step of initiation or trigger? Give us a little bit more detail of what this actually means and how it actually works.
Yeah, for sure. So the trigger part can be pretty much any application. So you have this ability to be able to connect to pretty much any application like emails, legacy systems, or web application, or webhook, or whatever. It is really important for companies to be able to flexibly connect with any applications. Because, well, let's take an example for the loan origination case like this one. The input of the information might come variety of system. Sometimes customers send those information through email, or if it's coming from a bank branch, or if it's car loan company, it might be subsidiary of the branch. They might use specific legacy system to submit. So there are a lot of cases that actual applications or requests comes from variety of systems, and it's important to be able to trigger the certain processes from multiple channels, which UiPath can handle because of the connectivity we have with API, UI automation, and so on. Yeah.
That's actually one of the things I love so much about the UiPath platform is that we talk often about this, the platform being a layer on top of your systems. And for UiPath, it doesn't really matter the system, right? It's a legacy application, it's a cloud application. Like for us, it doesn't matter. And what that allows the customer to do is not worry so much about the underlying applications because they have this smart automation layer sitting on top.
Mm-hmm.
So let's dive into the second step. This is extraction process, or what we might refer to as the data preparation robot. And as the audience will see on screen, this step here is leveraging a traditional robot, a deterministic robot, one that follows a programmed set of steps. And in this case, the robot is extracting necessary information from the application or multiple applications, leveraging OCR or optical character recognition, natural language processing, and then the agent converts the unstructured data into a structured format. And this can include things like the applicant's personal details, their financial status, their credit history, and really any information that's relevant to this process. So Masaki, dive into this extraction process leveraging a traditional robot.
Yeah, for sure. So once the whole process is triggered, we will extract the information from documents or email, which is very unstructured. And the beauty of using UiPath is we actually have specialized AI model to do such certain tasks, like classification of a document, extraction of a certain data from the data. Our solution name is called Document Understanding and Communications Mining, which are specialized in classifying, extracting information from documents and emails. And we leverage large language model on the backend, but it's better to use those specialized AI models over just a generic AI model. We've done the research about it, and the result says our model does better classification and extraction result for certain documents. So having the capability of really specialized AI model within a platform is going to be very beneficial in terms of the accuracy of the extraction or classification. And the overall process handling time is going to be much faster because now human needs to validate only few components rather than every single item lines.
I'm glad you mentioned specialized AI models because I think what's happening, we see this in our customers, is there's a lot of building everything from scratch, right? Which takes time and effort, and of course it's expensive. When in many cases, vendors, partners like UiPath already have specialized models built that handle things like documents, whether structured or unstructured, or unstructured email communication coming from a customer or a partner or a branch, as you indicated earlier. How important, Masaki, are these specialized models in reducing not only the cost to deliver a project like this, but also the time to deliver? Because everyone these days is under a time crunch to get things done faster and cheaper.
Yeah, it's a really good point. So training the model is usually very hectic part of the making solution, but because we have dedicated user experience, user interface to build the machine learning model for the specific task. For example, document understanding. If it's prompt-based extraction model, you can upload a bunch of documents, and you can write down the prompt to extract certain value from the documents, and you can see the result against the hundreds of documents immediately in really formatted way. So, and you can iterate the prompt over time to improve the accuracy. And once it's created, you publish it and you run that in a production environment, and all the actual transaction, extraction transaction will be fed back to the platform, so you can continuously monitor. We have a dashboard specifically designed for document extraction classification, so you can really monitor, and based on the result, you can continuously improve the model. And imagine you have to build all the portion that requires the continuous improvement. It will take a long time. UiPath already took care of it, so you don't need to build those components from scratch.
That's right. It really allows customers to stand these things up much faster, much cheaper. So it's just more scalable, right?
Exactly. Yeah.
Let's go back, Masaki, to the mortgage application process again, and let's look at step 3, the analysis step. This is really where the agent gets deployed, what we're referring to as a mortgage recommendation agent. So in this case, the agent gathers additional data from various internal and external systems. These could include things like credit reporting agencies, property databases, employment verification systems. Whatever the data that's required in this process, the agent can gather that. The agent then analyzes this data using machine learning algorithms. And basically what the agent's trying to get to, or will get to, is a credit worthiness score of the applicant to determine whether or not this loan should be approved. So, Masaki, tell us a little bit about this process. And I'm specifically interested in, how do you, well, I guess there's two things. One is, why have specialized agents? In this case, we call it the mortgage recommendation agent. So that's my first question. Why have a specialized agent? My second question is, how do you put guardrails and rules around the agent so they do exactly what you want them to do with the data that you want them to analyze?
Yeah, that's a great question. So to answer your first question, why we are designing agent in a specialized scope, like really narrow scope, the reason is simply the accuracy of the output of agent is going to be generally better when you narrow down the scope of the agent. So what you could do is, although probably in the slide it mentioned only one agent, it's likely we should divide the task into multiple agents. So the loan analysis agent would probably have multiple child agents. What it's gonna do is, the first agent, this analysis agent, is gonna take a look at some loan application and and do the reasoning and try to identify what kind of information should be retrieved from certain systems, and it could be multiple systems or web pages. And when it comes to retrieval part, the first agent can ask multiple child agent, which is specifically designed to extract information from the specific applications. So maybe child agent A will be in charge of retrieving information from public internet, maybe Google, the person's name or company's website, what kind of business it is, stuff like that. And then maybe agent B is LinkedIn agent, which will be in charge of matching the information with this personnel with LinkedIn profile. Or agent C might be in charge of internal system retrieval. So if this person has ever done any loan process with the company previously, research about the historical transaction, and you can imagine this could go keep going. And building deterministic workflow for each cases is going to be really hard. But we also have to think about the security around those processes. You don't want the agent to be able to access any application. Like, you don't want that. So that's why UiPath has this great balance of deterministic and the dynamic. So what you could do is you build the tools, like you make the automation to retrieve the information, and the agent will use the automation as a tool to retrieve the information. With this design, agent can't do anything outside of what's defined within the deterministic workflow. So LinkedIn agents can only access to LinkedIn, or agent C, which is in charge of internal system, can only access to internal system. And it can't do any spontaneous action that was not defined the rule-based approach.
That's really important, isn't it? Right? Because, you want agents to do what agents are really good at, right? Design, think, plan, reason, all these things that a traditional robot can't do. But at the same time, you want guardrails around those agents so that they don't get too creative on their own.
And on top of it, even if you design the automation not to be able to do any critical fault state, but you could also add a human validation portion before agent execute any of the automation. So, for example, agent might say, hey, I want to call this automation process to gain personal information from the internal system. The query input argument is going to be person's name, this email address, and so on. Am I right? Am I okay to execute this automation? You can set up the agent in a way so human can always validate it before automation will be triggered, to make sure the query agent is going to use is going to be always under the company policy.
And that actually gets to step 4. So if we go back to the example, we're looking at the mortgage application process. Step 4 is what you just described. It is that verification process, or human validation. So in this case, the agent is making, sophisticated calculations or reasons or decisions, right? It's coming up with whether or not this company should loan to this person. But the human person, the human employee, reviews recommendations or reviews things the agent wants to do, like you just described, to ensure that the decision that ultimately comes out of this is accurate, that it's compliant with standards that are set either by the company or by external regulators. And it really also allows for the leveraging of human intuition and discretion, which, let's be honest, are just something that an agent isn't able to do. So could you double click, Masaki, on this 4th step of verification?
Yeah, for sure. So the human validation portion in this step, the difference between this step and the previous one is the previous one was specifically validating which automation should be called, and the human validate that. For this step, the validation on a more business decision-making purpose. So validate if this loan should be approved or not. For most of the cases, you probably don't want agent just decide and keep processing. You want the human to validate still, but you can make the validating process very easy. So all the information that were collected by robot and agent will be presented in one single pane of glass, which is we are calling UiPath Action Center. That's where human can validate any business information that was raised by agent or robot. And you can design the action with low code, no code web application development tool called UiPath Apps. So you can customize the layout of what the information should be displayed in what way.
Yeah.
You probably want.
I'm really glad you mentioned. Yeah. Oh, sorry. Go ahead.
No, go ahead.
I'm glad you mentioned Action Center and that single pane of glass where the human can interact with the robot, right? Because like we talked about a few minutes ago, so many companies, as they're thinking about building AI solutions, if they're building these from scratch, that is another layer that they have to build in order to manage or orchestrate all of these things happening in concert. And that's generally speaking, both cost and time prohibitive.
That's absolutely right. Yeah, you hit a really good point. When you think about any agentic automation solution, agent part is actually, you can build pretty quickly because in the end it's just a prompt and the connection between automation, stuff like that.
Right.
But the true value or true differentiation will comes into other components such as human validation part. How easy is it to design the human validation user interface? How easy it is to connect with multiple applications? How easy is it to coordinate all the human validation part, robot and agent? All those things comes into the how can we actually bring value to real life?
Yeah.
And we tend to forget those portions.
That's right. Yeah. Okay, let's go to step 5 in this example. This is the mortgage application process. Step 5 is the update of the application. So this assumes that the application is approved. Now you have a traditional robot back in place, which is calculating the loan amount, the interest rate, maybe other terms, and then automatically updating relevant systems with these details, right? So this process of the deterministic robot updating systems based upon information that's relevant to this application does a bunch of valuable things, right? It eliminates manual errors. It guarantees consistency, which is particularly important in a financial environment like this one, where regulators may be overlooking or overseeing a company. They want to see lack of errors and consistency. But the third thing it brings to the table is speed, right? The robot, in this case, doesn't get tired. It doesn't take breaks. It doesn't take vacations, right? It just keeps working, regardless of the volume that's incoming. So can you double click, Masaki, on this application update process where we bring in another robot, what we refer to as the execution robot?
Yeah, so the last step is really about deterministic flow we are talking about, right? We don't want the agent to just do all the deterministic workflow, because as agent is really creative and it can make a dynamic decisions, but it might make a mistake because it's deciding the flow on demand. And a lot of business processing, including this last part of the loan origination processing, you don't need it to be dynamic. You don't need the process to be dynamic for the sake of being the dynamic. If it's something you can define really well, it's better to define in rule-based. So that's a really great, this step is a really good example of the rule-based approach, because once you have all the input, like the loan is approved, where we can get the interest rate calculation number from. In those cases, you just make the robotic process automation flow to calculate the number and where you should input those number to. You just build that automation deterministic way, and then you can do the full end-to-end automation. We can close the automation with that capability.
This goes back, Masaki, a couple episodes ago where we talked about how valuable agentic automation is going to be for companies of all shapes and sizes, right? It's going to change the landscape. There's no question about that. It's going to be amazingly beneficial and powerful for companies to deploy. However, companies still will need traditional deterministic or what you called rules-based robots in this orchestration flow, in addition to the humans that are part of the process. So I'm so glad you mentioned that you don't want the agent doing everything, right? That's not a good scenario. That's not a good way to structure this flow here. The right way to structure it is to have agents working alongside robots, working alongside people to get maximum value and drive the most efficiency into the process.
Absolutely.
I'm so glad you mentioned it.
Yeah, you hit the point. Yes.
Okay, let's go to the final step 6, in our example of the mortgage application process. And this is the final step where the company is communicating to the customer. And in this case, we have an agent deployed, which we're calling the customer communication agent. So like we talked earlier, we have specialized agents doing specialized things. This agent is a specialist in communication. It drafts an acceptance or refusal letter, depending on the outcome of the application. And then the agent knows or understands nuances of language, ensuring that the communication is clear, that it's respectful, that it's empathetic. And then the agent can actually send this communication by email, or it can prepare it for sending it via traditional mail, or both. So talk to us a little bit, Masaki, about the 6th and final step.
Yeah. So, Bill, as you mentioned, because agent is using large language model, it's really good at making natural language sentence, understanding the context of the situation. In this case, loan application request. So it will take into account what kind of request was sent, what kind of document was sent to the company, and it will all take that under the consideration to create the nice email and following some company guideline around what kind of language agent should use to send a message to the customer. And it can be very flexible in terms of the way it creates the sentence. It doesn't need to follow certain format because every loan origination situation is different. So that's a great use case of an agent to create an email to customers.
That's exactly right. So Masaki, this was exciting. I really liked going through a specific process for our audience. I think this probably illuminated for our audience how to think about processes. If you were to give the audience as a final parting gift in this episode, in terms of getting started, I'm sure they're thinking about processes in their own companies. What would you say to someone listening today who's thinking about initiating an agentic workflow that includes robots, agents, and humans?
Yeah. So I think the most important part is, first, you have to really understand the whole end-to-end process as is, like what's going on and what's the business challenge and stuff like that. And you really make the visualized version of this end-to-end process. With the UiPath, if you're using UiPath, you can develop the BPMN, which is their standard protocol for business process notation. You can design the business flow with this BPMN tool called agentic orchestration. And then once you build that and understand the end-to-end flow, you can start building, okay, this portion, we can make a rule-based approach. So let's build robotic process automation for this step. This portion might be a bit difficult. So let's start from the human validation, and you keep doing that. And you find, okay, this portion, we are doing that with human, but we actually might be able to build the agent for this task. So let's build the agent task, and you launch the production automation, and as you process, you can still keep improving the process. Okay, now we have 10 human validation step. Let's make this first step, human validation part, as an agent, replace it with the agent. And over time, the end-to-end process is going to be much more robust, and while you are still keep improving the accuracy and the consistency of the whole flow.
Yeah, that's right. That's good. Thank you, Masaki. Well, that's a wrap to episode 4. What I'll say to the audience is the white paper that we have been talking through will be available to download in the description of this video. Please like and subscribe and give us feedback on today's episode and what you'd like to hear in the future. But for now, that's a wrap to episode 4. Thank you, Masaki, and we'll see you all next time.
Thank you, Bill. Thank you all.